finally, the new Havoc's arrived. Of course, when that happens, it always raises the next question. How do we take all this stuff into one of these, the Havoc 340, brand new design, very innovative. Check this out. Look, we've got a GoPro mounted up front, and we have this thick carbon fiber to protect it in case we crash. These guys were not only designers, they were crash experience designers with quads. On the top, everything important is protected by this cage and these aluminum stays. In the back, we got a place where we can tuck our power cables so they don't get ripped off in the case of a crash. And on the bottom, our lipos are well protected by this cage of carbon fiber here as well. Now when we look like this at this angle, you'll notice that our cameras are kind of tilted up. And that's because this thing was designed from day one to be a screamer. I mean, super fast. So when this thing goes into warp drive, leads forward, the cameras are going to be perfectly level. So we're not going to be having any more shots of the ground flying by at high velocity. So anyway, there's a lot of lessons we learned putting this thing together, and I'd like to pass some of those on. That's the purpose of this video. So get yourself one of these and take a look. Okay, I know the first thing we want to do is open up this box and start screwing all these pieces together. But you know what? That's not the first step with a Havoc. This is a really different build. It's going to be a lot easier because there's this very innovative printed circuit board that they put together for us. Everything's built into this, and so 90% of the build is right here that we're going to do before we even put in the first screw. I mean, this board has the different power supplies built right into it. We're going to solder them in place. We've got filters. We've got a built-in OSD. You know how most builds are, when you have to wire, it looks like a spaghetti build or spaghetti quad. I don't think we're going to have it with a Havoc, because when you look closely, there's something I've never seen before. Even the ESC wires, the signal wire and the voltage from our BEC, is going to be wired directly through this circuit board. Pretty cool. Anyway, get your circuit board out and put the rest of this stuff away, because 90% of our build, we're going to start it right now. Well, it'd be kind of cool to have some power on our board, and there's a place for it. There's a place for a 12-volt regulator here, and we got a place for a 5-volt regulator here. Very easy to put in place. The only caution I would give you is that these packages, although the packages are marked perfectly, and I'll put the model numbers at in the description, but the regulator boards themselves are identical to each other. So there's no way to tell them apart once you take them out of the package. So wait until you're ready to use them before you cut the package open. Anyway, in the back of here, you'll notice that we have 5 pinnings. Voltage out, we got a ground, voltage in, and then we got a shutdown and one marked PG. We're not going to use the PG or the shutdown. We're only going to use those first 3 pins. When you get this in the package, there's a 5-pin header that you see here, and you might be tempted to try to either to snap it off or take a pair of wire cutters, but actually this plastic is kind of brittle. If you do that, it might shatter it. So instead, just get a straight edge razor blade, cut it off, and give yourself a 3-pin header. So what we're going to do, we're going to put it in place here and go ahead and solder it with the long pins pointing up, and then we will solder our board on here just like so. So go ahead and do that, and then we'll get to the 5-volt regulator. Alright, that's exactly what we're looking for. These last 2 pins, remember the PG and the shutdown are not going to be soldered in any way. There's nothing connecting them with the board on the bottom. Alright, let's get to the 5-volt. Now, you should know there's 3 places we can get 5 volts, so this regulator is actually optional if you choose to get your voltage from either one of the BECs, because if you recall, we're going to be plugging in our 5-volt BEC connection here from one of our ESCs. Another place you can get 5 volts is directly from your video transmitter. For example, some of the immersions supply a nice clean filtered 5-volt power supply. But in this case, we're going to go ahead and use this little Palulu. This is a model 2831. It's also 1 amp, just like the 12-volter, and you can see it looks exactly the same. There's no difference between the two when you get them out of the package. Again, we're going to only be connecting the voltage out, ground, and voltage in, and so I've already pre-soldered it, so you'll get an idea of what it looks like. And if I can get it in there, probably explains why I don't have any children. Here we go. It's going to look something like that. Again, those last 2 pins, don't connect them to anything. So go ahead and solder this one in place, and we'll get to our filters. This next step might be optional as well. We're going to be soldering on an inductor and a capacitor to filter our power. But as I said, optional. If you're going to be using 5.8 gigahertz or any of the immersion RC gear, they've got built-in filters and you don't need to worry about this. But if you're going to be using any of the other brands, some of them are sensitive to filter power. So we're going to take our inductor, and if you look closely, we see inductor. We're going to solder in between these two pads. An inductor is not polarity sensitive, so we really can't get that wrong. Just solder it in with one terminal in each, obviously. All right, we got the capacitor located here, a little bit obstructed by our regulator, but you'll notice it's got a plus, and so he is sensitive to polarity. And how do we know? Well, if we take a look at our capacitor, obviously some of them have minus or a white band like this one. Some of the capacitors coming out of China don't have that. The only way to tell is to take a look at the legs. And the one with the short leg, the one minus a little bit, is the minus terminal. All right, that's not too bad. All right, let's move on to OSDs. This board's designed to take the minimum OSD wire directly into the PCB. But it's really flexible. If you want to use no OSD, all you've got to do is jumper these two and your camera will feed directly to your video transmitter with no OSD information. If you want to use some other OSD, there's a video in and video out, just splice it right in there and it'll work. That's how flexible the board is. It is designed to take the minimum OSD, so let's talk about that for just a moment, and I can probably save you some money. If you buy your minimum OSD from the internet, off eBay, this is the version 1.1. This is probably the one that they're going to sell you, and it's the same price as the correct one. This is version 1.2, and they look identical except along the top you have this row of pins, and this is where we're going to get our flight battery information, our SSI, and a lot of other information off of these pins. So don't buy the 1.1, you're wasting your money. Get it 1.2, and I'll show you the link for that down in the description. Alright, there is a trick to this. You'll notice that there are 6 pins input on the side, but when you look at our board, it only needs 4. So what I'd like you to do is go ahead and solder a 6-pin header in place, and I'll show you how we're going to be able to communicate with this board after we've got it installed. Because after all, we're going to be talking to this board and programming it with this UART cable, and it's got to be able to plug in there just like that. So go ahead and solder the header in place, and we'll fit this OSD in. Alright, it should look something like that. All 6 pins on top and all 6 pins on the bottom. But remember, we only need 4 on the bottom. Well, on the bottom of the board, you'll notice that we actually have 2 grounds. Well, the board doesn't need 2 grounds. We only need 1. So we're going to cut off this outer one. And likewise, we're going to cut off that DTR. Now, this plastic on these pins, I'll warn you, is quite brittle. And if we just take our dikes and we start cutting, there's a good chance it's going to shatter and we're going to have to resolder everything. So what I'd suggest is take your razor blade, and I've already done it to this one, cut this to weaken it, and weaken this one as well. Then take your dikes, and see if I can get this centered here. Then we'll just cut off that outer pin, and we'll cut him off. So that we're stuck with 4 pins on the bottom and 6 on the top. Now, you might say, well, why didn't I just cut him off right here? Well, if we do that, the little pin will stick out just enough to short out on the top of the board. So go ahead and remove the pins completely like I've shown here, and we can avoid that hassle. Okay, we've got the minimum OSD wired up with the pins for these 4, but we also need to know, we want to know the battery pack voltage, and so go ahead and solder a pin in there. And we also want to route the video through the OSD so we can get that overlay. So solder those 2 pins in place, take your OSD, fit them in place, and let's solder them down. Alright, it's starting to look a little bit like a quad. All the pins are not cut nice and flush except these 6. And we're going to leave those hanging out there because later on, if we don't like the way the OSD looks, we can go in and change it. Just plug in your UART cable, reprogram it to the new look that you want, and unplug. If we cut these 6 off and we want to reprogram this later, it could be some major pain. We have to resolder everything. But anyway, let's talk about FPV cameras. So this would be the front of the quad, and we have a 12-volt power supply for our FPV camera. We see plus, ground, and a video feed right there, and then it's going to feed it through our OSD back to our transmitter, which is going to be coming out back here. Now I know there's a whole bunch of FPV camera guys, designers sitting around designing new plugs, because every camera I have in the shop here, they all use a different kind of plug and a different sequence of these wires. So I used to just solder this directly on there, but Fellas, I crash a lot. And usually when I crash, the first thing to break is going to be that camera. So then in order to change out the camera and the cable, I got to disassemble the whole quad, resolder a new plug on there, whatever it happened to be, and then put everything back together. It's very time consuming. So what I came up with a couple of years ago is just using a standard servo cable. It has 3 leads exactly like we need. And then whenever I get a new camera in, the first thing I do is just plug it into the female part of a servo cable. So if I crash and I need to swap out my camera, put a new one on there, I simply unplug from the servo, put the new one on there, rubber band it in place, and bam, I'm back flying. So let's do that here. Alright, it should look something like that. I'm going to take a piece of tape and just tape it down so it doesn't flop around while we're working on our video transmitters. Alright, I have no idea what video transmitter you guys are going to use, but this board will accommodate pretty much all of them. I don't know if you're going to be using a Lawmate, for example, something like that. It's a 5-volt supply, or something that comes off the LiPo battery directly. But you can take your 12-volt direct supply here if you need filtered. Your video feed is right there beneath your capacitor. And if you need the LiPo pack voltage, you can come off either of these 2 pads back here that the Havoc guys have provided for us. So I think on this one, I'm going to be using 2.4. But I've kind of done the same trick. You'll notice that all of these plugs, if I'm switching from immersion to immersion, the plugs are identical. But if I want to switch from immersion to something else, you can see those plugs are quite different. So I've done the same little trick on all my video transmitters as I have on my FPV cameras. Just used a servo. So immersions, since I'm using the 2.4, they've got filters built in, and they also have power regulators built in. They'll take anywhere from, I think it's 6 volts to 25 volts in. So I don't need to filter it. I don't need to double filter it. So let's go ahead and run our power back to one of these pads, and I will connect my video to that video out right there. Alright, piece of cake. We just route our cable beneath our OSD, come up to the servo cable, connect our video to the video lead right there, and now later on when we do the final assembly, all we do is we take our video transmitter and we just plug him right in just like that. It doesn't matter which transmitter we choose, it's going to plug in exactly the same way. Makes it easy to swap them out. Alright, I'm going to take a piece of tape and we are going to move him just like that, again to keep him out of the way, because the next thing we're going to do is connect our power lead. Now the power lead connects on the bottom, clearly marked plus and minus. And what we're going to do is come up through these 2 holes. If we connect it like this, the easy way, the first time we crash, the battery, the weight of the battery is going to pull on this, putting pressure, and it's going to rip those 2 foil leads right off of our PCB. Once those are ripped off, it's irreparable. We got to get a new PCB. So rather than do that, we're going to come up through these holes on the bottom here, like so, and then solder it to those 2 pads. And now the pressure is on this wire, it's on that solder joint, and it's on the connector. So the battery will pull away, or it'll tear the leads off here, but it won't put the pressure on those pads. So we get exactly what we want. So let's go ahead and solder that on. Alright, I think a herd of wild monkeys can swing from that, and we're not going to rip those pads off. So we got that in place. Alright, let's take a look at flight controllers. Plenty of room here to put pretty much any flight controller you want to. This we can accommodate the KK2, we've got Nage 32, one of their clone. This is a Dragonflyer 32, CC3D here. We can use the Tau Lab Sparky. This board accommodates pretty much all of them. And you see it's got common mounting holes, so we're going to go ahead. I know you guys have been looking forward to doing some screwing, so go ahead and grab the long screws, the 17mm ones, stick them through there, and use these small plastic spacers that come inside of the kit, and just thread them on there. So let's go ahead and put all 4 of those in place, and we'll talk a little bit more about flight controllers. Alright, there's our 4 bolts. Now I'm going to use a CC3D for the rest of this build, but they're all basically the same. They all mount the same way. The thing you need to pay attention to is that almost all of them have a recommended front. Usually it's indicated by a little arrow. And when you mount your flight controller, pay strict attention to where this USB port is. Now, although this is where they like the front to be, we can use the software when we program this to tell it that we've rotated the board, so it'll still work. In this case, we want to put our USB on the left side of the craft. So your battery connector's in the back, the flight controller USB will be on this side. The reason we want to do that is so that when we finally do assemble this and we put the side on it, they've cut a little slot in the side here to give us access to that USB. So if we want to reprogram the flight controller, or if we want to tweak our PIDs, we can do that without completely disassembling this. Make note, if we had assembled this the way that they want us to, in other words, putting the front to the front, that USB would have been inaccessible back here. So please make sure you put it so that it's on the left side so you can get at it. Now you might say, why didn't I put it on the right side? Well, good question. That's because over here is where we're going to have to solder in our header in order to attach from the ESCs directly to the pins on here. So in this case, here we can do the NAS 32, one of the clones. It'll connect 1 through 4. I think you can read that on there. If you're going to use the Tau Lab, Sparky, CC3D, we'll be using this one. So again, 1 through 4. If you'll pay close attention here, you see 1 through 4. And also, we're going to be using this terminal. Now, I need, for the CC3D, I need 5 volts. Almost any flight controller is going to need that. I'll get my 5 volts from right here. There's ground, there's 5 volts. And if I use the NAS 32 or one of the other flight controllers that can accept information from my transmitter and receiver, things like voltage, battery voltage, RSSI, things like that, we can pull that information from right there. So I'm going to go ahead and solder a 4-pin header here and a 4-pin header here, and then connect my cables to show you what it looks like. Okay, we've got the headers soldered in for the 5-volt supply to the flight controller, and we've also got all 4 of our ESCs are transferred from the board directly up here to 1 through 4 on our flight controller. So it should be pretty good. You see, I've got my PPM set up to, I'm using an Easy UHF, but whatever receiver you're using, go ahead and connect it now, because this is the moment of truth, fellas. This is the smoke test. So I'm going to go ahead and connect a 4S battery. Make sure everything lights up, nothing catches on fire, no popping noises, and none of that magic smoke. Looks like it's linking up okay. The receiver's working fine, getting its 5 volts, so everything seems to work. Only thing we need, we're finished with this board now, fellas, and the only thing we need to do when we start programming this is remember to tell it we rotated our board 90 degrees clockwise. Alright, before we get into putting the frame together around this completed PCB board, let's go ahead and prep some of our ESCs and motors to put everything together. On your ESCs, there's a couple of things you can do to reduce weight and improve reliability. So go ahead and take an X-Acto, slice down the side, and remove this shrink wrap. Now, in terms of improving reliability, we're not going to use these plugs. They are notorious for failing during flight. That almost always results in a crash. So instead, we're going to take our soldering iron, remove these 3 wires, and we're going to solder our motor wires directly to the ESC. So we're not going to use these, and since each motor has, each ESC has 3, that's obviously 12 pieces of wire, roughly 125 grams we're going to shave off of the weight. So pretty good weight savings. When you're done, it ought to look something like this. Go ahead and leave the tips on the power. We'll cut those off later. But there's one more unusual thing about this build. I forgot we're going to be soldering the signal wire directly into our PCB. So we don't need those long cables. All we need is the signal wire. So cut that cable off about the same length so that we got plenty of room, and then strip away that positive in the ground and just cut them off flush. We're not going to use them. Alright, let's move on to the motors. These are the new Cobra 2213s, 2000 kV. The 2213s have a little more torque than previous models, so I'm hoping we're going to get some pretty spectacular accelerations. So it's going to get to that 2000 kV really fast. The thing about these is you got this shaft sticking out of the bottom, and I think these were probably for airplanes originally. But when I put it up next to the arm, I noticed that that shaft sticks out, and I personally don't like that. It'll fly with it, and a lot of guys fly and it doesn't bother them a bit, but I don't want it hanging out there to hit something. So what I'm going to do, I want to cut that shaft off. But remember, your motors are full of some pretty powerful magnets, and if we cut that steel shaft, those fine metal filings are going to be literally sucked down inside of there, and that's not going to do our motor any good. So don't do it like that. Instead, get yourself a plastic bag, stick your motor in there, and then push the shaft through the plastic. And then get your Dremel tool and very carefully cut it off. You don't have to get it really close to the body, just get it above that notch, and then it won't protrude from the bottom of the arm. Take a look at it, you know exactly what I'm talking about. There we go. Finally, we're going to get to the easy part. We start putting this thing together, and fellas, it really is easy because the Havoc team has put together these, it's about 6 pages of step-by-step instructions exactly how this thing goes together. So I'm not going to waste your time. I'm going to start assembling this thing off camera, and when I get to an important part where you need to pay just a little bit extra attention, I'll stop and point it out. So let's start putting these screws in. Alright, after step 2 is the time to save yourself some pain later. Go ahead and take your Velcro battery straps, feed them through these 2 slots, because the very next step we're going to start closing off that space. So get access and get those in there while you can. When you get done with step number 4, these 2 arms are going to be completely locked down and your side plate's kind of hanging out there. Don't tie it down yet, because now we're going to set that aside. We're going to grab our motors and we're going to measure 4 centimeters or 1.5 inches from the body of the motor, and then we're going to cut these off. So do that to all 4 motors, and then strip them, of course, and we're going to be soldering them to our ESCs. Now these come out black, yellow, red, so solder 2 of them in exactly that order, and then 2 of them you're going to actually cross the wires. So it'll be black, red, yellow, for example. That's because we want 2 of our motors to go counterclockwise. So 2 normally, 2 straight out, and then 2 crossed wires. Go ahead and do that, and we're going to get back to putting these things together. Alright, when you get done, it should look something like this. You notice these are perfectly straight. So this motor is going to turn counterclockwise, and on this one we've crossed the red and the yellow wire, so this one will turn clockwise. So once you've got that done, go ahead and shrink wrap them up with the color of your choice. This red is nice and festive, and let's start mounting these. Now, when we mount them, this is the front. So the front right and the rear left are going to be clockwise, and then the rear right and the front left are going to be turning counterclockwise. Alright, we got half of them mounted. I'm looking at the front of the quad, so this will be the front right. You'll notice we got some crossed wires, and on the rear right we got straight wires. So clockwise, counterclockwise. I keep stressing that because I've made that mistake 100 times myself. Alright, next step, all we've got to do, it gets a little bit tight, but just fold the arm back a little bit, cut your wires to length, and go ahead and solder them in place. The pads, of course, are clearly marked. Okay, that first side now is completely done. I want you to go ahead and do exactly the same thing to the other side of the quad, and just go ahead and completely assemble it, because we're practically done here. Once you've got everything together, it really gets pretty easy. You just take your components, figure out where you want them, and tie them down. And that's what we're going to do here, but I do have one last trick up my sleeve. You'll notice I've got a weird looking little thing on the bottom that's not part of the frame, and it is a commercial electric tie-down base. There's 10 of them in a package, and they cost about $2. This is what they look like. They have adhesive on the back, and then you just slide a zip tie through it, and you can tie down pretty much whatever you want. The beauty of this is that when you put your component in there, you don't have to use double-sided tape to glue it down, and then later on you want to move it or you got to do some maintenance on it. You simply cut your zip tie. In this case, I'm going to put them in right there, and that's how quick it is to tie them down using these commercial bases. Really cheap, and for me really convenient. I use that on all of my quads. Another thing, I did it earlier because it's a little bit time consuming. I tied down my video transmitter, and you'll notice that I didn't put my antenna directly on the video transmitter. I could do it, there's plenty of room, but I mean, use this 5.8 as an example. When you do that, and ask me how I know, when you crash, your antenna will actually snap off this connector from your video transmitter. It's only got 2 small soldered joints there, and there's 3 on the bottom. They snap off and it breaks your board right there. Once you do that, you've lost a $70 board. So instead, get yourself some cheap insurance, one of these $3 SMA cables, and use the SMA cable to connect your video transmitter to your antenna wherever you want to put it. These are very inexpensive, and you can bend them and twist them and turn them. You're never going to break them, and even if you crash, this thing is well protected inside of this cage. You're not going to snap off that connector from your $70 or $75 video transmitter. So there you go, fellas. Everything's together. It's time to put some props on this thing and go fly.